Now I just got to find my copy of the test. Which exam did we give you? 4A?
Yeah. It should be on that counter.
I took it in there and brought it back in here with my computer, and I don't know where I put it.
Is it this? Oh yeah.
Is that another one? Does it say key on it? I got all the answers. And they're all written here instead of in my head. Okay, so let's go through this test. I asked that when you go through the test, like, keep an accurate score for yourself, so that when we're done, and we'll talk about what your scores are, but you'll want to say if you got it wrong, mark it wrong, and then circle the right answer because you're going to use this to study with. But I feel like it's very valuable if you know what percentage you actually got when we're done. So I'll read through the questions. If I feel like you guys don't have a lot of questions about it, we'll just move on to the next one. But if you have questions, you'd like to see how the numbers work, speak up, let me know what's on your mind. So number one, an energy audit indicates that replacing 50 100-watt incandescent light bulbs with 30 20-watt LED bulbs and 20 10-watt LED bulbs has an SIR over 1. How much money will this measure save in 1 hour if the cost of electricity is 12 cents per kilowatt hour? What'd you guys get?
C. 51 cents.
C.
C.
Yep. C. What'd you put, Kurt? Hey,
I have no clue.
Okay, that's all right. So C is correct. And really the trick to this one is just breaking it down, just trying to figure out have it on my camera. So let's do the numbers here for a minute. So it says an energy audit indicates that replacing 50 100-watt incandescent bulbs with a bunch of different bulbs, right? So first off, we're going to start out with how many bulbs?
50.
So 50 bulbs. And how much energy are they using?
100 watts.
100 watts each, right?
5,000.
So yeah, if you wanted to do the math on that, all 50 of those bulbs is using 5,000 watts, right? Because 50 times 100 would equal 5,000 if we turned them all on. We're going to swap them out with with 30 20-watt LED bulbs. So and with 20 10-watt LED bulbs. And it's saying that this has an SIR savings of SIR over 1. But the question is, how much money will this measure save in 1 hour if the cost of electricity is 12 cents per kilowatt? So basically, we're going to pretend that we're going to compare this to if we turn on all 50 of them in 1 hour, it's going to consume 5,000 watts, right? We want to know, instead of that, if we turn on all 30 of these and all 20 of these. So what would the math be on the 30 20-watt bulbs?
600 watts. 30
Six.
times 20.
Yeah, so we're just doing 30 times 20, which is the 600, basically, yeah. I can't remember how to drag all my zeros down, but so 600 here, and this one would be 20 times 10, or 200, right? So now if we have this new set of bulbs, the total from those bulbs is going to be 800 watts per hour. And we're comparing it to 5,000. So the question says, how much money will this measure save in 1 hour? So how would we figure that out?
You take 5,000 minus the 800 to find your difference.
Okay. Is that right? 4,200?
And then you divide by 1,000 to for the difference between 1 watt and 1,000 kilowatts. So
Okay.
I would divide that by 1,000,
So that would give us, if we're gonna divide this by 1,000,
4.2.
it gives us 4.2,
And then you
right?
times that by the electric cost per kilowatt hour, and that gives you about 51 cents.
So 4.2 times 0.12 equals
It's like 0.504, so you just kind of round up to
0.504.
Yeah.
So that's telling us that,
Since you're taking the difference, that's the savings.
it's saving us 51 cents, because we're gonna round that 504, because we really don't round that one down when we're talking about money, because if somebody wants money, they're gonna round up, right?
Yep.
Do you follow that one?
Yep.
Okay. Did anybody do it differently? Did you get to hear from there, Wes, or did you do it in a different way?
I'm trying to remember how I did it.
So
I can tell you
It
a
was
different way.
I definitely did it different.
You can take the 5,000 and divide that by 1,000 to get 5,
yeah, we could have.
and then 800 divide by 1,000 to get 0.8 or whatever, or 0.08.
Yeah. So we could have taken. We basically could have said, how much does 5,000 kilowatts cost, right?
Right.
So we would have divided it by 1,000 and then multiplied it by the 12 cents a kilowatt.
I think it's 60 cents or something.
Yeah. And then we could have multiplied this, which would be by 1,000, or divided by 1,000, which would be 0.8 or 0.80 or whatever you want. And then we multiply that by the 0.12, which is the cost of our electricity. And we could figure that out. What are you getting for the 5.0 times 0.12?
I got 6.6. So 5
You're getting 5
times
times 0.12.
0.6, so 60 cents.
So you're getting 0.60 or 60 cents, right? And then down here, you're getting somewhere around 8.5 cents, I'm assuming.
9.5, like, yeah,
About 9 cents.
0.096. So
0.096,
I mean, you could
Which
round that
is-
to 10 cents.
which
but
is exactly what we would expect there,
Yeah,
right?
right.
But basically, if we figured out how we were using 5,000 watts, we cut it down to 800, so now we could basically subtract out
60.
the difference of the 60 cents minus the 96, which would give us the 50.4. So there's a couple ways about it, but for me, I just try to break them down into little bits and pieces and try to, say, well, how much did this use? How much would I save here? And if that's not quite making sense, then try it in a different direction. Because these are those fun story problems that we all love from high school, and some of us did better than others. The guys that did better than others, we called them guys engineers. Now, and then there's us, right?
Yeah.
Okay. All right, next question, question number 2. So this is test 4A that we took, just for my video purposes there. Number 2 is while performing an energy audit on a home, you conduct a zonal diagnostic testing. With the blower door set at a negative 50 Pascal, you test an unfinished attic and record a reading of negative 12 Pascal with reference to the outside. This reading indicates what?
The attic is more connected to the inside. So the attic is more connected to the outside.
Yeah, outside.
It's with reference to the
I
outside.
switched it to
What did you say, inside or outside?
inside.
So you said the attic's more connected to the inside. You said it's more connected to the outside.
Outside.
You said outside. Okay. What I like to do on these is draw a picture. You guys find something that works well for you, but I like to just draw myself a house and think about what's going on here. So this says we're performing an energy audit, we're conducting zonal testing while we have the blower door going at a -50, right? So I like to just draw that right in my picture, and I say, here's my blower door, and I got it at -50. And then the next part, it says I'm going to test an unfinished attic and record a reading of -12 Pascal with reference to where?
Outside.
So where's my gauge?
Outside.
The gauge is either sitting outside or it has a hose going to the outside, right? And you can draw either one.
Yep.
What I'm going to do for the sake of this example is I'm just going to stick my gauge outside so that I can wrap my head around what it's doing. But so I got my reference tap, and I'm drawing the old 800s, but it's the same way with the 1000. You got your input and your reference, but for sake of it's a little easier to see. If this is my reference tap, then my input is taking a zonal on this attic. And I'm getting a -12 Pascal. So, and then it's basically saying, what does that mean? And we want to know, is the attic more connected to the house or not? So let's think about this for a second. If the attic was completely connected to the house, and let's not do this, because this is not what we normally do, right? What we normally do is we do this. We're in the house and we stick our hose into the attic. So let's just start there. If the attic was completely connected to the house, what number would we expect to get on our gauge?
-0 if it was completely.
A -0, because by turning the blower door on and depressurizing this zone, if this zone was completely connected to this zone, then there should be no pressure difference between the two, right? So yeah, we would expect a 0 since it's whatever the pressure is in this zone with reference to whatever's going on down here. We would expect a 0. So if this was a -50, then it would mean that this zone is completely separated. On this gauge, if this was a -12 inside the house, then what would that mean about that zone?
It'd be more connected to the inside.
Yeah, because it's if we wanted to completely connect to the inside, it would be a 0. So since it's closer to 0 at a 12, then we know that it's more connected to the inside than it is to the outside. But now we're going to flip that right on its head, because we really, in this scenario, we took it and we said, okay, now the reference point is outside. So same scenario. Before we start thinking about the 12 and whatnot, if we stuck our probe up in here into this, and we wanted to, and if we stuck our probe up in here like this, what number would we expect to get if the attic was completely connected to the house?
-50.
Yes, you following me on that? This time the gauge is outside. If we're depressurizing this box right here to a -50, if this was completely connected to it, then us standing out in the yard and sticking a hose up in the attic, we would expect that to also be a -50. If this thing was completely isolated, we have a really good air barrier there, it's completely separated, then we would expect it to be at a 0, which would be the same pressure here and here. But in this case, we actually had a -12. So the -12 in this scenario means that, so we wanted it, 0 would be completely disconnected from the house, 50 would be completely connected, right? But on our little scale of 0 to 50, we're over here at a 12, which was closer to being disconnected than to connected. So I don't know if drawing this kind of stuff would help, or if drawing this would help, or anything like that. But that's what I end up doing if I can't get through the whole thing in my mind while I'm taking the test, then take your scratch paper out and just start drawing the picture. Make make sure you go back and reread the question and stuff. Does that help? Does that get us, so that the answer to number 2 is B, that the attic is more connected to the outside. So, and sorry, the terminology I used here doesn't really align, but this would be completely connected to the inside. This would be disconnected or more connected to the outside.
Sometimes the with reference to trips me up a little bit.
Yeah, I think
Just have to
that's
pay attention to that.
Yeah.
starting out. That's what I couldn't wrap my head around for the longest time. So if you know that you're trying to compare it to what you've set your blower door inside that house, and then however close they are to what you're trying to compare it to, is what you gotta wrap your head around.
That's the thing that it took me a while as well. It took me like 3 years. But then I finally started thinking about what my little gauge said, and my gauge says input and reference. And I was like, oh, wait a second. Here's my input, and then this is with reference to is always going to be whatever's going on there.
I had the right answer the first time, then I went back and changed.
You rethunk it. That's what you get for overthinking it. That is, I'm glad you say that too.
Just go with the flow.
So Wade did a really good job of explaining that. They've done some studies that it's like 75 or 85%. It's a really high percentile. That high percentage of the time, your initial thought on what the correct answer was, is going to be the right answer, especially on these multiple choices. So, like, if you'll keep that in mind, and then go back and reread the question. But if you're really still lost, then go with your gut. You'll probably be right. Okay, number 3. We're rocking and rolling here, right? While performing an energy audit on a home, you determined the client used 485 gallons of propane during the previous heating season. Approximately how many BTUs did the homeowner use?
I couldn't remember how many BTUs for propane per gallon is. Because I can remember 139, I think it's natural gas. 139,000 for 1 gallon is natural gas, but I couldn't remember if that's propane as well. So I have like 2 different answers depending on what that.
So
I done it times 1,000.
one gallon of propane has approximately 91,500 BTUs in it. So now it's approximate because not all propane is created equal, right? And also it depends on the elevation you're trying to burn that propane, you're going to get a different amount of BTUs out of it. So it's approximately, I think on the test you will have a formulas sheet. It may have that information on it. I can't guarantee that though, so this is a number you'll probably want to remember. Okay, so now that you know that, how do we find our answer?
Times that by
91,500 times 485 gallons.
Okay. So what do you get if you multiply 91.5 times 4?
444,377,500.
Lucky guess.
44,375. So yeah, B is the correct answer. You guys feeling good about that one?
Yeah.
Number 4, while evaluating a homeowner's natural gas usage history, you subtract the annual baseload usage from the annual total usage. This is known as what?
I said C.
C. What'd you get,
I
Wes?
said D, but
D. You said
D.
Okay, so D is determining the home's heat loss, heat gain. C is determining the demand gas usage. A, determine the 6 month gas consumption. B, determine the space heating requirements. Okay, so let's go back to the question. While evaluating a homeowner's natural gas usage, you're subtracting the annual base load from the annual total usage. And this is known as what? Are there any key indicators in that question for you?
Usage.
So we've got usage. What kind of usage are we messing with?
The gas.
Gas usage.
So we're talking about gas usage. And it's talking about base loads, right? What's base loads versus what's
Water.
the other thing? The total usage, right? But tell me what base loads are on in a house. Why do we call them
Water
base
heater. It's the things that are always on so that they have immediate use. Things that always have to be.
Considered a base load?
What's that?
Is fridge base load too?
Say that again for this deaf.
Is that fridge
Oh,
considered
the
a base
fridge,
load too?
yes. Yeah, so base loads when we're doing a home energy audit are gonna be refrigerators, lighting, and water heating. And I don't know, I kind of think about it a few different ways when I'm thinking about base loads. First and easiest way for me is I think about the energy audit, and they put all of those on the base loads tab. But then it took me like 2 years into the program before my brain finally thought, oh, wait a second, these are base loads because, and it's because those are the loads that the occupant they're gonna flip them on and off whenever they want them, and they really don't have anything to do with the heating load or the cooling load on the whole house. And so that's how I separate them into two piles. It's basically how much energy is this house consuming because people are living in it versus how much energy is this house consuming because they're trying to heat it or cool it. So I don't know if that helps in any way or not, but that's the difference between base loads versus just, and I like to call it your heating and cooling loads. But in this case, they're using a different term. The correct answer is C, that you're determining the demand gas usage, which I don't like because it can be confusing. Number 5. Arriving at a home to perform an energy audit, the homeowner informs you that 3 of the 5 bedrooms in the home cannot be accessed because people are sleeping in them. In this situation, you should do what?
Let's see. Gotta reschedule.
C says inform the homeowner that the audit must be rescheduled if you're unable to access the entire home. Yeah, that's going to be the best answer there. A said knock on bedroom doors to inform occupants they must leave the rooms. That's really not something we would do, at least not in that harsh of a way. Inform the homeowner that failure to allow access to enter the entire house will result in a denial of service. That's not quite accurate. And then perform a partial audit on the home and reschedule another time to audit the bedrooms individually. That would kind of be a waste of our time. So all of those have some elements of options you could probably pursue if it fits the situation, but C is going to be the most correct or probably the best option. So, and that's another thing you'll want to watch for on this is pick if you're not sure if a couple of them sound right, pick the one that sounds the most correct. Number 6, while performing an energy audit on a home, you perform zonal diagnostic testing with the blower door set at 50 Pascal and find an attached garage that is at 19 Pascal with reference to the home. What should you include in your work order for this home?
The air signal walls shared by the garage and home.
That's what I got.
Same. Yeah, and that's, so D is to air seal the walls shared by the garage and the home. Why is that? Why would that be the correct answer?
Because it's showing a stronger connection to the house, and you don't want any of the air that usually is in a garage that's harmful getting into the house. So you want to seal those off as much as you can.
Yeah, so we've got this wall right here we did a zonal, so here's our zonal, our gauge, got a hose going over here through that door. We're finding that that zonal is at a 19 parts, or 19 Pascal, sorry. What would we want it to be at?
Closer to 50.
We want it closer to 50, right? Because that would tell us that this air barrier here was good and that this garage was not really connected to the house. So since it's way less than that, we've got some strong connections there, and exactly what Dan was saying, that we don't want to pull the exhaust fumes and other, chemical fumes and whatnot from the garage into the house. That is why that is the highest, I think it's the highest priority, or second highest priority.
Outside of duct sealing, I think.
Oh yeah, duct sealing is the highest priority, and then that's gonna be your second highest priority. So that's why the answer to this one is gonna be air seal off the walls shared by the garage and the home. That should be included on your work order. Number 7, while performing an energy audit on a home built in the 1960s, what's the most likely health and safety concern you might encounter? What'd you guys put?
Lead-based.
I put, B.
Lead-based paint, lead-based paint. What'd you put?
I would assume lead-based paint, but I put all of them.
Okay, so it says, so A is knob and tube wiring. Lead-based paint is B, rock wool insulation C, asbestos steam pipe insulation. So what would be the least likely one that you would run into?
Probably not.
I'd say we'll leave the.
We're still working on it too.
Yeah, I think not. For a 1960s home anyways.
That's my point here is, like, you're gonna have differing opinions.
Yeah.
This is a great example of choose the very best one, and the answer here is lead. It's not the perfect question, but it's a good example of, you could find all of those things in there, but the best answer is going to be lead. So, number 9, typically, where will you find the most significant source of air leakage on any given home?
What number we
You
have?
skipped one.
Yeah, we're on
We're on
8.
Number 8, to accurately determine the age of additions or improvements made to a dwelling, which of the following resources would be the best starting point for research of relevant records? It says
I wasn't really sure on that one, but I put B. Taxes.
B. What'd you put? A. So A is a title company, B is the tax assessor's office, C is the mortgage holder, and D is the
right answer now that I think about it.
Yeah, so B is the correct answer. A title company may have some of that information, but
My brain ain't working very good today.
you're okay. And a title company isn't going to have publicly accessible records. Really, and it's the same thing. The mortgage holder's not. The State Department of Housing, same thing. And they don't really keep that stuff. But yes, a lot of agencies use the information from your
Did we do that?
tax assessor's office or from the land records department or whatever of your county or your local cities for that kind of information. So, number 9, typically, where will you find the most significant source of air leakage on any given home? What'd you guys get on that one?
B. Attic bypasses.
Attic bypasses?
My experience has been almost A all the time, but I don't think that's right. But I wrote down A.
I almost
You got
wanted
A?
to pick D, but I picked B.
So A was windows and doors, B is attic, C is electrical outlets, D is exterior wall penetrations. So what's an attic bypass?
Chase.
Yeah. So we're typically talking about, let's say we're up in an attic, here's some top plate, and we've got a masonry chimney, so this is bird's eye view, masonry chimney coming out, and they did pretty good with their drywall, but they left this gap right here open, so we have like something that goes down this masonry chimney, goes all the way to the basement. That's typically what we're talking about when we're talking about an attic bypass. There could also be lots of smaller bypasses and stuff like that, but I think that is probably why, because it's a big giant hole, that's why that one's gonna be correct. Yes, you're going to have air leakage from other areas, windows and doors, electrical outlets, and other penetrations, but most significant, I guess you could make a fair argument for that one. So, but again, these can be a little bit subjective, objective. I can't remember which the right term there is. One's right, it's subjective. Yes, I think. Number 10. While performing an energy audit on a home, you find a vented attic behind an insulated knee wall. With the blower door set at -50 Pascal, you perform zonal diagnostic on this space with reference to the home. Which reading confirms alignment of the pressure plane with the thermal boundary?
I said A.
I said D.
A, D, Kurt.
I said A.
Okay, well,
Going back to our
D
first,
is correct.
going back to our first question we done, I can see why D is the right one now.
And same thing here, I like to draw that picture. So it says, I'm performing an energy audit on a home, and I find a vented attic behind an insulated knee wall. So, first thing I'm gonna do, I'm just gonna use this picture, and I have a vented attic. So, let's say that this attic out here over the garage is my vented attic. Is that a good? Maybe I better draw a better knee wall. We won't use that one. We'll say that this has a second floor up here. So we got some living space up here, maybe a collar beam, some knee walls. And we'll call this, we'll say that this is our vented attic right here. So we've got some attic vents here, and they might, go through the floor joists, and there might be a ridge vent up there that's allowing the air to move through there. That work? So vented attic. While performing an audit on a home vented attic, with the blower door set at -50, we perform zonal diagnostics on this space, which is the vented attic, right? And it's with reference to what?
The house.
Yeah, so our hose is going to be in the house, and it's going to be going into that attic. And we're referencing the house, right? And then it says, which reading confirms alignment of the pressure plane with the thermal boundary? I don't love this question because the answers don't really confirm an alignment of the thermal and pressure boundaries. The answer does confirm which shows that the pressure boundary is complete. And if the pressure boundary was complete, meaning that, we've got a nice solid pressure boundary here, and then wherever else it goes. We would expect that to be what?
The exact opposite.
Yeah, we don't want it to be 0, because if we took the hose off and we have the gauge in the house, it should say 0. We want it to say 50 because we are depressurizing the house with our blow door. So, now we have a -50 and a +50, and that gets even more complex, right? So, you may have a good way of describing why or what the difference is.
It's because
I've
the
always-
pressure
I struggle with
outside
this.
the house is going to be 50. If that's vented, that's letting that pressure be the same as outside. And
Yeah.
if you're completely sealed off, that's why
It
it should be
coming up
complete.
as positive instead
It
of
should be
negative.
exactly opposite of what the house is.
Okay, and maybe we could test that while we're out there messing with our blower door this week and show that, but that's, honestly, I found myself so many times when I'm out in the field that I don't pay attention to the sign on the gauge. And I really haven't taken a ton of time to wrap my head around that, but so if we're putting this under a negative pressure, then if this is completely separated, then it should be positive. It shouldn't be negative. That help? Does that just make it worse?
I'm still confused on that for sure, but I don't know, because I was just thinking if you were inside the house and tested an attic, maybe, I don't know, maybe it's just the negative part is what's messing me up. I just feel like if I see -50, I would still think that it was completely separated from the house.
It would be if we, like we normally do on the audits, but we're doing opposite.
Yeah, I think you are falling into the same thing that I've done. When
So
I'm
that's
doing
right,
that,
I
I
got
gotta
it
pay
wrong
attention
too,
to what
right?
the sign is. But what the sign should actually be positive when you think about it. But let's draw it out and think about it a little bit more. So take the hose off the gauge, and the gauge will tell us what?
0.
It's 0, right? But we have this whole house, we have it under a negative pressure, right? So it's actually like sucking in on all the walls around us, right? Because we got our blower door moving it at -50. So if this is under negative pressure, if we stick our hose out anywhere outside, how would we ever get a more negative pressure? It would always be more positive, right?
Yeah.
Because we have that space under negative pressure. I don't know if that helps.
Well, that's,
Yeah.
that helped me out a lot.
And again, just what we would expect if this was 0 from inside the house, then, instead of a 0, we would expect that to be a 50, and it should be positive. So unless there's some really weird phenomenon going on outside, it should be a positive pressure. But okay. That was number 10.
Yeah.
Number 11. While performing an energy audit on a home, you find several open electrical junction boxes on the ceiling plane of an unfinished attic. What should be included in your work order if the attic is going to be insulated?
Let's see.
Did you say C as well?
C. Yep.
Sorry, I am a little hard of hearing, so I apologize for saying what a million times. C is correct. You need to cover the junction boxes with approved covers. Number 12. Which test instrument should be used to measure the draft pressure on an atmospherically vented water heater? A. Yeah, A is a manometer. What does a manometer do?
Test pressure differences.
Yeah. Just measures pressure, and that's our DG 700s, 1000s, 300s, 80s, whatever you've got. They're all just manometers. If you have a back rack, the back racks have, in addition to doing combustion analysis, they also have a manometer on them. I think the E instrument does as well because you can measure pressure. So a lot of those gauges have a manometer built in, but the manometer part really just measures the pressure differences. So, number 13. While measuring CO levels on a gas oven, you record a reading of 445 parts per million before taking a CO reading in the natural draft water heater located in the home. What should you do?
I changed my answer on this one, so hopefully I didn't screw
A.
myself.
I
I
put
put C.
What did you put?
C.
You put C, A.
I had A originally.
Okay, C says red tag the oven and inform the homeowner that it must be replaced. A says run your analyzer in ambient air to clear the current reading. So let's read the question again. While measuring CO levels on a gas oven, you record 445 parts per million. And then it says before you go and take your reading on the natural draft water heater, what should you do?
Yeah. You should
And
clear
A
your-
is
yeah.
correct.
Yep.
I was looking at a combustion tape for this on this exact thing just last week. In fact, give me 2 seconds, I'll pull it up and show you what I found. Maybe. I can. this is what I found. And ignore the words for a minute, because it'll give you the answers. Can you read the numbers on that tape? So this one's, top one says boiler, bottom one says water heater. And the top boiler has a CO, says XXX. And this was on a back rack. Whenever the back rack goes up beyond its, whatever the thresholds that it is set to measure, it'll just say XXX. That just means it's above. It has, the CO is higher than that level. So they measured a boiler and they pegged the meter on CO. And you probably can't see this very well, but the time on this was at 12:06 p.m. Then they went down at 12:28, so it's been 20 minutes later. They measured the water heater and they got 493 parts per million on the water heater. When I saw that, I thought, there is a chance that that auditor forgot to clear out their back rack, because you got two appliances sitting next to each other. Both of them have really, really high CO. There's a chance of that. There's a chance you have problems with combustion air and a few other things. But my first question for them is that, did you actually clear your combustion analyzer before you took your next test? So anyway, thought it was kind of interesting little example of that. Now I got to figure out how to get the camera back on. There we go. I think it's on. And I'll make this go away. Another, my favorite example of this though was my older brother. When he was in college, he was at a party. The cops came and kind of busted up the party. And my brother decided, when the cops, were questioning all of them, he decided to mess with the cop, which was a mistake. And so he started slurring his words a little bit and just acting a little bit drunk, even though he wasn't. And the cop caught on to this, but he decided to mess with my brother in return. The cop had a portable breathalyzer, and so he pulled out the breathalyzer and he put a new little breathing tube on it, and he made my brother blow in the breathalyzer. And he watched the color drain out of my brother's face when he blew like a 1 point whatever. And he started laughing, and he said, "Okay, blow again." Because he knew he had never cleared the breathalyzer since his last test.
Oh.
So when my brother blew a second time, he was clean. But that's what you get for messing with a cop, right? But it's the same principle. Like our combustion analyzers, they're pulling the combustion gases into the gauge and they're measuring it. And if you get something that really has high CO, really you should be clearing it between every measurement, but you got to pay close attention when you get something that's really, really high, and then you go to measure your next appliance. I actually called Backrack last week and talked to them about that, and the guy said that they recommend running it for 5 minutes before if you peg it that high. He said 5 minutes in outside air before you take your next measurement. So anyway.
I turned mine on outside and couldn't get mine to go. It kept reading 2 parts, automatically, but it was a smoky day, so I don't know if it picked up CO just,
Yeah.
But anyway, then the furnace was high on CO. Then we tried another, we had somebody bring another back rack just to test it. It was fairly consistent.
Gotcha.
So I don't know if the outside must have just had CO or something. I don't know.
Yeah. It could have had CO. It could be time for your gauge to be recalibrated or something. I think I would have had a tendency to be like, all right, I'm outside air, so I'm going to baseline this, and whatever I get, I could really subtract 2, but it's probably time to either change the sensors or have it recalibrated or whatever your gauge requires. So. Number 14, is it 14? Yep. Yeah, so 13 was A, run your analyzer and ambient air. 14, which of the following conditions can cause an atmospherically vented forced air furnace to backdraft? B. B. Yeah, B is to return duct leakage in the CAS. So we have an atmospherically vented forced air furnace And to get at the backdraft, yes, return air in the CAS would definitely do that. So if we have a CAS and we have some duct work and we've got our return air going into our furnace, so our supply is going up. As the return air is going into the furnace, return duct leakage in the CAS. So we're pumping air into the supply, right? So the air in the supply, if we had a leak right here in the supply duct, would that be pressurizing the CAS or depressurizing the CAS?
Pressurizing.
Yeah, we're pushing air up, and so we're pushing it into this duct, and therefore if it leaked, it would actually pressurize the CAS. And then on this side of things, we're actually pulling air into the furnace. So if there was a hole right here, it would pull air out of the CAS into the duct and into the furnace. And if the furnace had open combustion and it's pulling air here, that air will be pulled from the path of least resistance, which could very well be that combustion air, or the vent on the furnace, which it would cause that furnace to backdraft. So that is correct. Number 15. High stack temperature on a combustion analysis correlates with what?
I put C, but I was kind of lost.
B.
I put B, but I'm not sure now.
Okay, so what is stack temperature? What are we talking about here? It seems like a term we're not super familiar with.
That's the flue temperature.
That's the flue temperature. Stack is another word for flue. So high flue temperature could mean what? Let's just think about that in general. What is the flue temperature or stack temperature of a normal natural draft water heater?
400, 350.
Yeah. It's going to be right around there, 300 to 400, something like that. What's the flue temperature of a high efficiency furnace, 95%?
100.
Yeah, it's going to be like 80, 100, somewhere around there, right? So which of those two appliances is more efficient?
The furnace.
Yeah, the furnace is. It's 95%. Or if we wanted to take an example of an 80% efficient furnace with, open combustion, have you looked at your flue temps on one of those? That one's going to be around 300 or 400 as well. The high efficiency appliances, you typically run the exhaust through a secondary heat exchanger, and they drop the flue temps even more. So really all this question is pointing out is that the higher the flue temps is just an indication in general that the appliance is probably less efficient.
So that would
Because-
be C is the answer.
So
I just got it in my head when you watch the backtrack on the flue temperature, your CO goes down.
So 15 is C, lower efficiency. Number 16, while performing an energy audit on a home, you find the following condition. A full container of gas and oil soaked rags next to the furnace. What should you do next? D. Yeah, so A says make recommendations to the client. B, move the items to the nearest bedroom. C, ensure there are no signs of flame rollout and all pilot lights in the CAS are off. And D is just terminate the audit until the items are removed from the home. So, yeah. All of the other options are, kind of right, but D is the most correct. 17, what is the recommended flow rate in GPM or gallons per minute for a residential low flow shower head? B. 285. B. It is B. That's what we recommend in our program. 2.5 gallons. If you put in 1.5 gallon, then the wife is going to call and yell at you. Or she'll yell at her husband for letting those dang weatherization guys into their house. Yeah, 2.5 gallons. 18, while reviewing a client's electrical consumption, you find that they use a 1200 watt electric cooking griddle, an average of 4 hours per day. They also use a 2100 watt electric oven for 7 hours a week. What is the yearly kilowatt hours used by this client for cooking? What'd you guys get?
I totally guessed on that.
I guess and put C.
I put C.
I put D, I guessed. I didn't know how to do it.
Kurt, I take back what I said earlier. Don't go with your gut. Your gut's off by 1. The answer is C, but let's do the math on this one. So, this is one, and in the test, so when you start the test, you actually are going to have a number of different questions. It's not always a 100 question test. It actually, sometimes it's a 70 question test, sometimes it's a 55 question test. And what it's going to do is it's going to tell you that you have X number of questions, you have X amount of time or Y amount of time to complete the test, and it's typically about 2 to 2.5 hours. And then it will tell you what your score, your minimum score has to be. And it's usually somewhere in the 70s, but it actually changes on every single test. So they just look at, and they'll say, this test is actually a little harder, so your minimum score only has to be a 72. Or if whatever random stack of questions came up for Wes's test, then it'll say, well, this one's a little easier, so you actually have to get a 77 in order to pass. But regardless of how many questions you have on the test, you should have plenty of time. This is a question that I would probably skip past while I'm taking the test. Like if you know you're gonna have to sit and do some math, I would just skip past it. I would leave it blank and go on to the other questions if you're feeling like you don't have time to do it, and then come back to this one and do the math on it, if that helps. But here's one way that you could do the math. So, and it's just, again, break the story problem down. So we have a cooking griddle that's 1200 watts and they're using it 4 hours a day. We have an oven that's 2100 watts, they're using for 7 hours a week, and we want to know what the yearly kilowatt hours is for cooking. So 1200 watts times 4 hours a day. And 2100 watts times 7 hours a week. And we need to figure out what the total is in years, right? So, how would you guys go about doing the math?
I'd figure out how many total hours for each appliance.
Okay.
So the first one is going to be, you take 4 times it by 365 just to get your hours. And then 7 by 52 for 52 weeks. You get that total hours.
So you're converting, in this case, you're converting weeks into a year.
Yeah.
So if it's 7 hours a week, you would multiply 7 times 52.
Yeah.
Because there's 52 weeks in a year, and that would give us what?
364.
So 364. So we're saying at 21 watts, 7 hours a week, it's 2100 watts times 364 hours per year, right?
Yep. That gives you your kilowatts. Many times those two.
And then how do we convert this one from hours into a year?
That's, you do, so it's 4 hours a day, so you just times 4 by 365 to get your total hours in the year.
Because there's 365 days in a year, so what are we getting on the math on that one?
1460.
1460.
Yeah.
So again, that is 1460 hours
in a year.
per year. So So now we still gotta figure out, we're looking for kilowatt hours per year, right? So to get hours per year turned into kilowatt hours per year, what do we do?
Times each hour per year by the wattage of the device
So we times this
by
times
1200.
this.
Yep.
And that would actually give us hours, kilowatt hour, well, watt hours.
Watt
per
hours,
year. And
right.
we'll convert it into kilowatt hours per year,
Right.
right? Yep. So let's do that. So 1200 times 1460 is what?
764,400.
Say that again.
764,400.
And that is watt hours per year. And
To get to a kilowatt.
do you want to convert kilowatts now, or do you want to convert them?
Yeah,
It doesn't matter.
I mean,
Whatever's
I
equal.
did it now, and you just divide it by 1,000 to break it down to how many kilowatts it actually is.
So just simply divide this by 1,000, right? Which is, we just move the decimal point on this over to here.
Yep. So
When we divide by 1,000, so we really just have 764.4. So 764.4 is now kWh per year, right? You following me on that conversion? Okay, so we did that for the griddle. Let's do the same thing here. So this was the oven. So we got 364 hours per year times 2,100 watts. So 21. Sorry, my math gets very messy, but it usually works, right? Yeah. Times 364 equals what?
1,752,000.
1,752,000,
And then divide that by 1,000.
and that's watt hour year. So we divide that by 1,000, just moving that decimal point over by 3. So now we're at 1,752 kWh per year. So we got 764 and 1752.
Add them up.
So we just add them together, right? 1752, 764.4 equals what?
2516.4.
2516.4 kWh years. You guys comfortable with that? And again, the question is, what's the yearly kilowatt hour? So the answer is going to be that, just kilowatt hours, because you don't actually have to include the year in there, because that's what we're answering. These were the questions that always threw me off. I did not do well in physical science, because I'd always get these story problems and I just couldn't figure them out. But honestly, if you'll just take a few minutes and then and break them down and test and do this, but then when you're done, if you want to, go ahead and test it. How could we test this answer? To test it, you'll take the answer and plug it in wherever it might fit, or you actually take the answer and kind of work the problem backward a little bit. So in this case, we would say, well, 2516.4, what if we times it by 1,000? So now we're at 2,516,000, 400. So then you can go, well, did that add up to what we had here? Or you can even work it backwards further, which gets a little more complex, but you could basically break it back down into hours per day and things like that if you really want to test it further. Another thing you can do though is think about just what it's telling you and compare that to what you've seen in the field. If you've looked at any of the combustion, or not, the consumption charts and things like that, think about how much you've seen clients actually consuming and make sure that it passes the make sense test. The one that's at 251,000 doesn't pass the make sense test. The other ones are a little more plausible just because they're smaller. But anyway, you guys good on that one? Number 19. What is the area of a solid core wood door that measures 30 inches wide by 6 feet tall? See. Cool. What's the formula for area?
Width times height.
Yeah, width times height. There will be a formulas worksheet that may have the formula for area on it that you can use as a reference. That one seems simple. There's a few other formulas on there that might come in more handy. 20, are we on 22?
Just 20.
Just 20. $21. 20. Oh, there it is. While performing an energy audit, you record the following dimensions of a single-story home with a vaulted ceiling. Interior dimensions are 32 by 53. The exterior walls are 8 feet tall, and the peak of the vault is 14 feet from the finished floor. What's the volume of this home? D.
I got that wrong because I couldn't figure out how to do the voltage.
That's okay, because I would
I
like.
did it from the middle of in middle of 8 and 14.
Yeah.
Got 11. I don't know if that's what you're supposed to do.
It can work. Generally, you're gonna be closer to it than not, so.
Yeah.
And unless
Yeah,
you end
some
up
of
having
those
to insulate and get a more accurate number, and then you can go into it a little bit more, but just do it midway point usually works.
Okay. We have a house. And it has a footprint of what?
32 by 53.
So this is 32 feet long, and this is 53 feet long. Is that right?
Yeah.
And then it has walls on it that are how tall?
8 feet.
8 feet tall. So 8 feet. And then it has a roof on it, and it has a vaulted ceiling. And what did it tell us about the vault?
It was 14 from the peak of the vault is 14 feet from the finished floor.
Okay. We have to make an assumption here. Which way do you suspect the vault is going? Which way do you suspect the trusses are running on this house? They're probably 32 feet in length.
Yeah.
They're probably not 53 feet in length. Right. So if that stuff is missing, go with what's going to be most common or make the most sense. So we have some sort of a vault on here that runs this way, and it said from here to the top of the vault is 14, is that right?
Yeah.
Okay. And we need to know the volume of this whole space here, right? Like, we're looking for the volume of that container. So, how do we figure out volume?
Length times width times height.
Length times width times height. So what I like to do on these is I like to break it down into smaller pieces so I don't get too confused. So I would like to figure out the volume of this cube down here, and then I'd like to figure out the volume of the top part. So tell me, what is the volume of the cube?
13 by 68.
What is it?
13,568.
And you got that by 53 times 32 times 8.
Yeah.
That. Okay. And then, So let me just draw the side or the end of that vault there. And we'll say it's a scissor truss or something, but we're just after the vault. And this is 8 feet, and to here is 14 feet. How far is it from here to here?
6 foot.
6 feet. And how far is it from here to here?
32.
32. So, and then we've got 53, right?
Right.
It's the bottom area. How do you figure out the area of a triangle?
I did length times width times height divided by 2.
You did the length of
I did, yeah. I
the
did 32 by
length
53 by
times
6.
width times height and divided by 2. Why did you divide by 2?
Because it's not a square, it's a triangle. You have to account
It's half a
for-
square, right?
Right. So,
So whether this is a right angle or not, basically if you took any triangle and you took the mirror image of that triangle, you would end up with, let's say that this is 6 feet here and 8 feet here. Well, if you took the mirror image, this would also be 6 feet, this would also be 8 feet. So now you have a box, whether it's like a rhomboid or a square, it doesn't really matter. You have a box that you know you can go length times width on. And if it's a triangle, you go length times width and divide it in half. So length times width divided by 2 will give you the area of a triangle. So, and then same thing. So you actually took the volume of the whole thing, pretending it was a square.
Yep. 53
times 32 times 6, and then you divided the whole thing by 2, which is correct. What did you get on that one?
18. Yeah. So, without dividing it by 2, it's 10,176, and then when you divide it, it ends up being 5,088.
5088. And then what do we do?
Add them together.
And so we're taking this plus this. So 13,568 plus 5,088 is what?
18,656.
How you feeling about that one?
Right now.
Yeah, just break it down into little pieces. Figure out the area, figure out the volume.
I think I just got lucky on that one.
Or just,
It's actually a good trick that does actually work when you take the difference of the 2 different heights
Yeah.
in the middle and just times it. You'll get real close at the very least. So.
yeah. Okay, was that 20?
Yeah.
21. While performing an energy audit on a home, you find a bathroom exhaust duct fan or fan duct that is run into a soffit. What should you include on your work order for this home?
A.
Yes. A is to rerun the exhaust duct and terminate it directly to the outdoors. Why?
You need to vent exhaust fans to the outdoors all the time because it will negatively impact any insulation that's in the attic. You don't want to create moisture problems in there.
Yeah.
It could recirculate in the attic if there's, the pressure grounding.
The whole point of an exhaust fan, it does help to clear the air in a bathroom when you're in there, using the restroom. But the main point is to move the bulk moisture. We don't want to move that bulk moisture and dump it out into the soffit. We actually want it to go all the way outside. So yes, we would add that to our work order in general. We can get into the semantics of that later. But number 22, as the infiltration rate of a home is reduced, a draft hood equipped combustion appliance becomes more susceptible to which of the following?
A.
Yes. What is a draft hood equipped combustion appliance?
Natural draft furnace.
Water heaters usually.
So it's just that. It's going to be open combustion, natural draft, and the draft hood usually has a spot where some additional air can be entered into the equation. So yeah, it would definitely be susceptible to vent system spillage. 23, which of the following variables does ASHRAE 62.2/2016 take into account when determining the recommended ventilation rate?
B.
What'd you put?
B.
B. Yeah, B is the number of bedrooms in a home. So A, the number of smokers, doesn't matter. C, the number of windows in the home. Windows only come into play when we're looking at kitchens and bathrooms, so we don't care about the rest of the windows in the home. And the number of combustion appliances in the home, we don't account for that when we're calculating ASHRAE at all. So 24, while performing an energy audit on a home, you conduct zonal diagnostic testing with the blower door set at -50 Pascal. You test the crawl space and record a reading of 4 Pascal with reference to the home. This is an indication of what?
A.
So A says the crawl is very connected to the outside. B, the crawl is equally connected to the house and to the outside. If B was correct, what would our zonal be?
25.
Yeah, so we know B's not right? And then C says the crawl is very connected to the house. D, the crawl needs more ventilation installed. In general, and this is kind of one that falls to our program, but in general here in Utah, we're not adding ventilation to a crawl. There could be a few situations where you might want to, but so I would probably throw D out of it, and this is probably a question of, is this more connected to the inside or the outside? So read the question again. You're performing an audit on a home, conducting zonal diagnostic testing. With the blower door at -50, you test the crawl space, and this is with reference to the home. So we're standing in the living room, and we're putting our probe through the floor. If that thing is completely outside, what number will we get?
It costs me 50.
And if that thing is completely inside, what number will we get? So if it's, let's draw us a little scale here of 0 to 50. And since we're inside, 0 would be completely connected to the house. And this would be completely outside. So what's our question asking? What does 4 Pascal mean? So 4 is going to be right over here. So what does it mean?
To the house.
C, the crawl is very connected to the house. You all right on that one, Kurt?
I got it right, but I just switched my answer real quick too.
Oh,
Just tell me
let's switch back. Go with your gut again. You just need to know when to go with your gut and when to not go with your gut. Do they have a manometer for that?
Yeah.
All right, 20.
So wait, you said it's connected to the house, right?
Yeah, the answer is C. It's very connected to the house. 25. What is the best way to determine if knob and tube wiring is active?
D.
Yeah.
D, I got that one.
It's not A. Ask the homeowwer. I would never trust that answer. Yeah, the answer is D. Check the wiring with a non-contact voltage tester. There are some other ways you could do that, but from the list here, the county records won't really tell you. The fuse box with screw and bus fuses, that's not necessarily an indicator of whether the system's live. 26. While inspecting a furnace, you note the manufacturer lists a, do you guys know what that triangle stands for?
Delta T.
Delta T. What is the delta? What does that mean? Delta.
Change. Difference. Change in turn.
Yeah, difference.
Or difference, yeah.
Yeah, so it's going to be the difference in temperature. So the manufacturer lists a delta T of 35 degrees Fahrenheit to 65 degrees Fahrenheit. You measure a temperature rise of 73 degrees. What could be done to correct this?
D, I guess, but I could see.
D.
Why did you guys put D?
Because it's not moving air enough. It's heating up that thing. So when you move the fan to a higher speed, it's going to move that down and actually reduce the temperature.
You're on the upper end of your limit,
Yeah.
or over your limit.
You're over your
upper end.
the high end of your limit, right? Yeah. Yeah, so And Wes, this is not just for you, this is gonna be for everybody else who watches this and you know. But anybody who's new to furnaces, we got a furnace. Inside the furnace, we have a blower motor. And the blower motor, in this case, will have it blowing air going up. So maybe it'll suck air from, you know, around the cabinet this direction, but it's basically gonna push air up. And then we have a heat exchanger in here. And our burners, we light our burners, and the burners actually run the exhaust through the combustion part of the heat exchanger. And then our blower blows air around the outside of the heat exchanger. And this question is basically saying we have a temperature range. We want to keep the temperature of the air inside the heat exchanger, inside the furnace. We want to keep it somewhere between, was it 35 and 65 or something? But in this case, it's gone higher than that. So what do you do to cool that down? If you can increase your fan speed and blow more air across the heat exchanger, it will actually bring that temperature down. If your soup is too hot, what do? You pull a spoonful of it up and you blow on it to cool it off, right? So you're just gonna increase that's one thing you can do, is increase the speed of your fan. It'll bring the temperature down. If you have that capability on the furnace you're working. What number was that?
26.
Okay. So D was the right answer. 27. While performing an energy audit on a home, you measure the carbon monoxide in undiluted flue gases of a Category 4 furnace and record a level of 250 parts per million air-free. According to the BPI 2017, the 1200S 2017 standard, what should you do next? C.
I put C.
B, C.
I thought it was 200.
C, I guess, because I need to.
It's 200
Some more.
diluted air.
So, while you're taking the test, you will have a reference, and it should give you a reference to the BPI 1200 standard. This is one that you can look up. While you're taking your field exam, you should also have in your possession some reference charts which reference the 1200 standard. And so we have the quick reference chart, which gives you all the steps on doing a worst case draft test and your ambient combustion, like indoor ambient CO levels. So, but when you're talking about your appliances, there's the chart right there. BPI is not as concerned about having you memorize everything on this chart. They want to just make sure you know how to look stuff up. So that's why they'll give you this on this written test, so just look it up. And when you're out in the field, you'll actually have to reference specific things on here, so we'll show you how to take the time to look it up. So Wes, what is that chart telling us in reference to this question? And I'm gonna hand both of you guys your stuff if you want to. You'll be bringing this out in the house this afternoon, but there's the chart and stuff.
I got the truck, the briefcase in the truck.
Gotcha. So this says, while performing energy audit on a home, you measure the CO in undiluted flue gas of Category 4 appliance, and you measure 250 parts per million air free. According to the BPI 1200S-2017 standard, what should you do next? So the BPI, we have adopted the BPI 1200 standard. And this really is, the standard includes, like, this is how you run a worst case draft test. This is your ambient CO levels. These are your appliance thresholds. So you can go straight to this chart, and it's saying we have a Category 4 what?
Furnace.
So is there any differentiation between a Category 1 and a Category 4 furnace on this chart? It just says furnace, right? So what are our CO levels on furnaces allowed to be? What is it? 400 parts per million air free. The question says we measured 250 parts per million air free, so how are we doing? Are we within the standard? So what's the answer?
C.
C, no action is required. This is an acceptable level of CO.
This might be done, but what's the wall furnace BIV?
I
What is it, GIV?
BIV.
don't know what VIV is.
Let me look at that.
It's probably
There's
something
direct vent and then there's BIV.
VIV. The vent, the V might be a vent. We could Google it. I'm not certain.
I'll look it up later.
Okay, 28. Oh, let me say one more thing. So the BPI 1200 standard, there is a BPI 1100 standard. I don't know that you'll come across that, but they may provide that for you. When they wrote the 1200 standard, they said this standard includes everything in the 1100 plus all this other stuff. So if they provide the 1100 standard for you, know that that is part of the 1200, which is what we've currently adopted, but more importantly is exactly what they're testing you on. So if it says so on the 1100 or the 1200, they basically just decided, let's not rewrite this, let's just take this plus add a few more things. So either one of those standards, they're really one and the same as far as what you're getting tested on. 28. During an exterior inspection of a home, you find an area of uninsulated wall which is missing the exterior cladding. In this situation, you would most appropriately what?
I have no clue.
C.
I put D.
I put D. What, this is 28?
Yeah.
Yeah,
Yeah.
I put D.
So A says use an IR camera to evaluate the wall section. If it's missing exterior cladding,
You don't need to see through it.
yeah, I wouldn't think so. You'd probably be able to see into it, but maybe it has exterior sheathing but no exterior cladding. I don't know. So that one seems a little iffy. Seems like we would need more information there. And I don't know what you'd really do with the IR camera other than say yes or no, it's got some insulation. B, ask the homeowner to contact a construction company. Not really in our wheelhouse. C, evaluate the structural integrity of the area being insulated. Yeah, that's part of what we do as an audit. D, include a patch as part of the work in order to insulate the area. So D is correct and D is allowable. Why would we want to put exterior cladding over something that we're going to insulate?
So it's not getting ruined. And
Yeah,
so you're
that-
making an error.
Are we talking about
Barrier.
sheeting or like vinyl siding and stuff?
It's
Exterior cladding.
exterior cladding. What is exterior cladding? What's the exterior cladding out here on this house?
Vinyl. Or I don't remember.
We've got like some laps, like either wood or fiber cement lap siding on that house, right? And it's got some brick veneer. That's the exterior cladding. Exterior cladding's vinyl, stucco, it's that kind of stuff, yeah. So basically what this is saying is you could consider an incidental repair to make sure that that insulation you're going to add to the wall is not going to get ruined by getting rained on, things like that. You have to make a few assumptions on that question. It's not the perfect question, but hopefully it gets the point across that you can evaluate that. But yeah, the couple of clues on that one where you know that the wall has no insulation in it, the IR camera's not going to do much for you. We typically, you could tell the homeowner they might need to contact a contractor, but we wouldn't really say it like that. How would we say that? If it was a big enough issue that they actually needed to do something first, we would defer that.
Right.
So we wouldn't tell them what they have to do, we would just defer the job. Anyway. 29, while performing an energy audit on a home, which information must you collect in order to determine ventilation needs for the home?
C.
C. Total square footage of the home. 30, which of the following materials is acceptable for venting residential oil-fired furnaces?
I put A.
Is it B? I think it's B.
I put the feet
If I'm
in.
remembering
I can't remember the
RMGA at
difference.
all.
And if you wanted to Google L-vent on Googly search, it'll tell you that is for oil-fired furnaces. I don't have any experience with it. They just did the research one day, and that is what it's called. I don't know if they're double, single, triple wall. I don't know. But type L is for oil. So the answer is B. 31. While performing an energy audit on a two-story home, you find wall cavities which are open from the top to the bottom. Your work order for this home should contain what?
Would be
The ceiling, both top and bottom wall.
That is correct. B. 32. While performing an energy audit on a home, you need to determine the type and approximate R value of insulation in a wall cavity. What is the best method for accomplishing this?
A.
Yeah, A says drill access inspection holes as feasible in all exterior walls. B says drill holes in all closets in the home. Why would that be wrong?
closet's not always going to be.
Exterior walls.
Yeah.
Use a blower door and an IR camera. You can use an IR camera. The blower door is actually going to throw things off. So that would be why that one's not really the best option, because it's going to start accentuating stuff based on air leakage. And then asking the homeowner is not very reliable. So A is the most correct. C could be correct if you did it before you kick your blower door on. But anyway, 33. When measuring an existing window for replacement, you should record which measurements in order to ensure the correct replacement window size.
D.
D is in dog. It's the width, the height at both ends, and in the middle of the window. Why are you measuring it in the middle?
Seen a lot of windows that have sagged or the structural around it is compromised or I don't know. See some wonky houses.
Yeah, you want to make sure there's no sagging or anything that's gonna make it so your new window just won't fit. 34. A door measures 36 by 80. What's the square footage of the door? Sorry, that's 36 by 80 inches. What is the square footage of the door? Yes. You guys comfortable with the math on that? Because B and D would be some good guesses, and if you run enough audits, you'd know that 36-inch wide door is going to be 20, but I want to make sure you know how to do the math. So, how do you do the math?
36 times 80 divided by 144.
Why are we dividing by 144?
Because it's feet squared.
How many inches are in a square foot?
Yeah.
Yeah, so we multiplied 36 by 80 to convert that into the total square inches. And there's 144 square inches per square foot, so we're going to divide it by 144 to get it into square feet. Which of the following is a driving force for radon entry into a home?
C. I put C.
C? Yeah, C is correct. A negative basement pressure. And this is why, if this is our, here's our crawl space under our house, right? If this is under a negative pressure, then it's going to be pulling radon out of the ground, right?
It's easy to remember that air goes from high to low pressure, so it's
Yeah.
negative.
So it's always going to be moving from positive to negative. Yeah. That's a great way to think about it. 36. If a 14 by 14 living room has a vaulted shed roof with a 12 pitch, what is the approximate area of the roof?
It's
I gotta remember how I did that. Right.
What'd you guess, Kurt? You look like you had to make a guess on that one.
Hey, but I can't remember what I did to it.
Okay, the one thing that throws people off on this question is the shed roof. What's a shed roof?
That's a great question, and I think you have the answer.
Do you guys know what a gable is?
Yeah.
Do you know what a dormer is? Or just trying to think of some other roofing terms. What about a Dutch hip?
No.
Or so on a wall, this end right here, if this just goes straight up, so the side view of this would be, your wall was up, this is just a flat pitch here, that's a gable, right? If this was a hipped roof, it would look like that, right? Yeah, sorry, I guess I have to,
Your pitch goes right
here's
to
my box from the top, and so if this was a hipped roof, it would look like that. That's a hip. If you have a gable, but it's clipped right here, that's called a Dutch hip. If you have a roof, I think you'll see this most of the time. Well, that's this we can use this. You know how they do the garage unders on some of these houses, and a part of the garage, like this whole part of the house sticks out further than like the front door's back here, and then, or maybe just the garage sticks out, and they put the roof over the garage right there. Well, that from the side, so here's our garage sticks out to here, and they put this roof on there like that. This half of a roof is called a shed roof. Like that can be long and flat, can be steep, tall, whatever. There's also some a bunch of different other roof configurations you can talk about, but that's really all it's talking about. It's saying the configuration of the roof is a shed roof, which is going to be, it's not a full gable where you have two slopes. It's just a single slope going from high to low. It's a shed roof. So with that information, let's draw a picture of this. So which question is it? Number 36. We have a 14 by 14 living room, has a vaulted shed roof of 12 pitch. We want to know what the area of the roof is. So we know that the footprint of our room is 14 by 14, right? And then on top of it, we got something going on where we have a shed roof, right? So from the side of it, it's really just going to look like that. And we know that this is 14 feet, or that this is 14 feet. And we know that it has a 12 pitch. What's the 12 over 12 pitch? What does that mean?
How many inches out versus how many inches up?
Yeah. So
It's 1 foot.
yeah, the pitch is just it's just a ratio. So they would draw this as we had a 4 pitch. We'd say it was a 4/12 or 4 over 12. But all this is that it's the rise over the run. So you would, if you had a roof and you were going to measure the pitch and you said it was a 4/12, what that means is that for every 4 inches that you go up, then you go that direction 12 inches, right? So in this case, for every 12 inches we go up, then we're going 12 inches over. You can also, we typically refer to them as 12 or 4 pitch. It's more proper to say a 4/12 because in some instances people will put that over 18 or over 24, things like that. But in general, it's always over 12 in the United States. So if it's a 12 pitch, then that means that, what does that tell us about our triangle? Can we derive the length of one of these two sides based off the pitch? And what would that be? For every 12 inches we go up, we go 12 inches over, right?
Right.
Which means that if we went 14 sections of 12 inches that way, then how many of sections of 12 inches would we go up?
14.
Yeah, so we know that this is 14. Because that is 14. Or what would it, does it tell us anything about the angles or anything we have on this triangle?
No.
If this is a 12 pitch,
Oh, yes,
Then-
that's right.
we actually have a right angle down here. And that, if the length of this leg and the length of this leg were exactly the same, then we would also know that these are both 45 degrees. That may come in handy. In this case, it's really not that important, but it may come in handy when you're thinking about whether you can use Pythagorean's theorem, because we do have a right angle there. What's Pythagorean's theorem? Does anyone remember?
Is it a squared plus b squared equals c squared?
Yeah.
What's that?
Yeah.
That is math. What's a what?
So A would be like 14. B would
Yeah.
be 14. C is, you would just do, so, yeah.
So Pythagorean's theorem works if you have a triangle with a right angle, and A and B are always going to be the legs that make up the right angle, or C is always going to be the leg that is opposite the right angle. So what it says is that if you took, let's say that this one is A, and you squared it, and you added to this one, also squared, then it would equal whatever this is squared. So in this situation, we are trying to figure out what the area of the roof is, right? So when we're done, we want to know how big this area is. And we don't know what that is until we know the length of this, because then once we have that, then we can say, well, it's 14 times that. And that would give us our area, right? So we got to figure out how long this slope on the roof is, and we can do that by using Pythagorean's theorem of a squared plus b squared equals c squared. Does anybody know what 14 times 14 is?
196.
Because that's how you would square it, right? So 14 squared is 196 plus 14 squared, so 196 equals
392.
392. Is that our answer?
No.
What do we got to do with that?
Find the square root.
You times it by itself.
Would you say, Wes?
You find the square root of 392.
Yeah.
But
So you guys familiar with the square root button on your calculator?
Yeah.
So just hit the square root, and what that's going to do is it's going to figure out what times what equals 392. What is the square root of 392?
19.79.
So 19.79 would be the length of this right here, from here to here. We're at 19.79. So if we need to know the area of our roof, we know this part's 14, that part's 19.79, we would just times those two together, right? Get the area. What does that give you if you multiply?
277.
So, on question number 36, it says, what is the approximate area of the roof?
Yeah.
Is there a number there that's close to 277?
280.
So our approximate answer is 280. Square, S-cubed, square feet. That makes sense? Long walk that we got there, okay. How you feeling about that one, Kurt?
A little off, but.
I think we'll have
Brain's on.
I think we'll have another question like that. Hopefully, when you get to it, you'll be able to walk yourself through it. I think you'll see that one on tomorrow's practice test. Okay. 37. Which of the following actions are part of preparing a home for combustion appliance safety testing? B. Yeah, B as in boy, it's close all exterior doors and windows. Why would we do that? What, I guess first off, what are the combustion tests that we would do that for?
Worst case draft,
Worst case draft.
and you combustion analyst, I guess.
Yeah,
I don't.
if you were just gonna do a combustion analysis of an appliance, you'd want to close the doors as well, otherwise, you know, it typically is just going to be that worst case draft test, and typically it's closing the doors would not affect, if you had a closed combustion or sealed combustion appliance, it should not affect that. So really, we should just be talking about worst case draft testing, but there could be some circumstances where it would also apply, like you're typically gonna test that house with all the windows and doors closed, not necessarily have them open. So, number 38. Which of the following factors would determine the type of diagnostic testing performed in a home? B. Yeah, B as in boy, it's the type of heating and cooling equipment in the home. And really this one was just the diagnostic testing that we're doing within the weatherization program. That's going to be the most correct answer. 39. While conducting an initial interview with a client, you should ensure that they understand that the energy audit will do what? B. A. A, what'd you say, Wes?
B.
D is in dog?
Yeah.
Okay, why would D be incorrect?
Because we're guaranteed.
So A is correct. Provide information about potential savings. So we're running the numbers on paper, but in the real world, we have no control over how the client interacts in their home. We also really don't have any control over, we have less control over how effective our air sealing and things are. When we're running the audit, this is what we hope to do, but it's not an exact science because we have to let humans do the work. Number 40. If it takes a shower head 25 seconds to fill a 1 gallon jug, what is the shower head's flow rate?
A. I put A.
Y'all put A. Why did you put A?
Well, it would be 2 gallons per minute if it took 30 seconds to fill a 1 gallon jug. It's just under that to fill it, so it would take a little bit more. I didn't do the math exactly. I
like,
I
yeah,
have
so you kind of did a shortcut where it's like, well, 25 seconds is close to 30.
Yeah.
So if it was 30 seconds,
it'd be at 2.
then that's half of a minute. So if it was 60 seconds,
It's a little faster than that, so it's gonna kick out just a little bit.
I like
I
that.
don't remember how I did it, but I typed it in the calculator and got exactly.
I did 60 divided by 25.
60 seconds divided by 25 seconds equals 2.4. And yeah, since we're dealing with 1 gallon, we just want to know what fraction of 25, or what fraction of 60 25 is. 25 goes in 62.4 times. So in a full minute, at 1 gallon, in 25 seconds, that's how many you would give us, 2.4. 41. What is the predicted annual kilowatt hour consumption of a refrigerator if a watt meter indicates that 0.82 kilowatt hours has been consumed during a 4-hour period?
I put A. I don't know how I got
I put A, but I put a question mark next to it.
Okay. Kurt, tell me what your thought process is on this one. How would you figure this one out? So what are we trying to figure out?
What is the predicted annual kilowatt consumption of refrigerator?
So,
A watt meter indicates 0.82.
so we want to know how many kilowatt hours the fridge is going to use in 1 year, right?
Okay.
And what information do we know about it?
4 hours at 0.82.
0.82 what?
Kilowatt an hour.
Kilowatt hours. So we have kWh at 4 hours. So if we're after kilowatt hours per year and we have the kilowatt hours in 4 hours, we don't have to change anything. We're not, changing this from watts to kilowatts or anything, right? We're already where we need to be. So we really just need to figure out, instead of running this for 4 hours, if we ran it for a whole year, how much would that be? So how do we do that?
You take 0.82 and try to figure out how much that is in 1 day as opposed to 4 hours. So you times it by 6. So you know what it is at 4 hours, times it by 6 to get the full day, and then times it by 365, you got your full year of kilowatt
Yeah,
hours.
so that's usually those are the steps that I usually take. First thing I'll do is be like, okay, that's 4 hours. I want to convert this into days, and then I want to convert that into a full year. What's another way that you could do that instead of multiplying it by 6? Multiplying it by 6 is usually the easiest. What if we'd run it for 3 hours? Then what would you multiply it by?
8.
Yeah, and it's because we're trying to figure out what 3 plus, or sorry, not plus, times x equals 24, right?
Yeah.
Or in this case, 4 times x equals 24. 4 times x would be 4 times 6 is 24. 3 times x, that's 3 times 8 equals 24. That's why we're doing that. So we're converting it to 24 hours. And then we know that there's 365 24-hour periods. Another way to do it would be, well, I ran it for 4 hours. What if I just divided that by 4 and got back down to 1 hour? And then I could multiply the whole thing by 24 and get up to 24 hours. And then multiply that by 365. So whatever's simplest for you. This is usually the simplest way. But yeah, so let's we got the 4 hours, or sorry, that 0.82 kilowatt hours at 4 hours. So let's times that by 6. So we're going to take 0.82 times 6.
4.92.
What is it?
4.92.
4.92.
I did that right.
360.
So that was times 6. And then, so that gives us kilowatt hours per day. How do we convert that to years?
365.
What do you get, Kurt?
1795.8.
1795.8 kWh. Does that number look reasonable? Before you even go looking at the list, what kind of kilowatt hour ratings are you guys seeing on refrigerators?
I'm seeing lower than that. That seems to be higher.
Yeah.
1 point something.
What would you normally see on like a 24 cubic foot fridge? Have you guys paid any attention to that?
I've seen a lot of bigger fridges lately, but even they are not even half of what that is.
So
And if they're newer, they're way lower than that.
Usually on like a 24, 26 cubic foot fridge, I'll see them somewhere between 800 and 1200 on average, if they're running efficiently. A little 18 or 20 cubic foot fridge, you'd see that I've seen some fridges even down close to like 300 and 400 kilowatt hours per year. The bigger fridges, especially the ones with the separate freezer and the French doors and stuff, they end up actually having 2 motors on them, and their power consumption, that's why you'll see the kilowatt hours up around 1200 on some of those, because they're just using a ton more power. So at 17, would this be unreasonable? Or would that just be a really
It's just not preferable.
inefficient fridge?
Yeah, it's just inefficient.
That to me says just really inefficient. Now, if it was, I don't know, 11,795, I would think I did my math wrong.
Yeah.
But at 1795, I'm feeling pretty comfortable that I probably did my math right, just based on what I know about refrigerators. So the answer on this one is A, 1796. That's all I would do to do math. Does that help? Cool. 42. What's the primary reason for determining the age of home?
I was thinking we had.
D as in dog.
Yeah, I got this, that's like.
Yeah, so the answer is D as in dog. Older homes can be subject to historical preservation guidance. B, older homes present significant health and safety. That is correct.
The primary reason is,
What's that?
but the primary is the historical preservation.
Yeah. And really, again, it's like, what's the most correct answer here? If there's something that's just a little clearer, a little more specific, go with that. If B said older homes present or could have the presence of lead paint in it, then I'd be like, oh yeah, it's B and D. But since it's a little more vague, D ends up being more correct is all. So the answer is D. 43. While performing an energy audit, you test a shower head and find that it takes 50 seconds to fill a 5-gallon bucket halfway. What is the flow rate of the shower? B. That could be B. 3 gallons per minute. How did we get there?
Can't remember, but
I just said it was almost a minute.
The math is, you take 50 and times it by 2, because that's only half of the, that 5-gallon bucket. So you get 5, or you get 100 seconds, and then you want to divide that by, let's see, if I can remember how I did this. So you have 100 seconds to fill 5 gallons, so it's 100.
I done like 50 times.
100 seconds. So you do 100 seconds, and I think you divide that by, no, that's not how I did it either. Just
I did
did it.
something with 2.5. I remember doing something with 2.5. I just can't remember what I did to get there.
So we have 50 seconds. And this is, you can go about this a few different ways. The way that I did it is I divided the 50 seconds by the number of gallons that I got during those 50 seconds. Because I was looking for a nice round number that I could then go, well, how many gallons or how many chunks of that time or whatever. So 50 seconds divided by 2.5 gave me 20. So what that is that in 50 seconds, I got 2.5 gallons, or in 20 seconds, I have 1 gallon. And how many 20-second segments are there in a minute?
3.
There's 3. So basically it was then just 60 divided by 20 equals 3. That's how I got there, but that's not super clear. Like,
Yeah.
And I've always struggled with these. Like the guys in my physics class, they just knew all the formulas and stuff. I have the tendency I got to just think through it. I like that you were trying to just take a number that you know you can double or divide by 2 or something that will help you get there very quickly. I feel like you can reason your way through most of these things because they're really not that complex.
Tomorrow, we just write our math down off to the side on our practice exam.
Yeah, you're welcome to.
Then I can remember
Then
how
you
I
can
did it.
remember how the
I
heck you
remember
got there.
2.5, I just can't remember.
Yeah.
Anything after that.
Yeah, so at 50 seconds, we got 2.5 gallons. Are there any other ways to figure that out? You guys breaking this up in any other way in your heads? You could, I'm just wondering if you could basically figure out like how much you're getting every 10 seconds and then multiply that by 6. That, which is really all we did here. Because we took 2.5 gallons divided by 50. That's not quite right. Anyway. I wish I had a cleaner way to tell you exactly how to do that every time, because this is the opposite of or a little different from how I showed you last time. But anyway, might have to do a little homework on that, see if I can find some better ways to show you guys that. Number 44. Which of the following would be considered a baseload appliance when referring to energy consumption? C? Yeah. So is an air conditioner baseload? Nope. Is a furnace baseload? Nope. Is a heat pump baseload? No. Oh, they all have to do with heating and cooling loads on the house. 45. What's the volume of the following home? It's 45 feet long, 35 feet wide, 8'6" high. D. Yeah. And you got there by just multiplying the length times the width times the height. So D is 11. Now, why is it not C? Why is it D instead of C?
Because it's cubic feet because you're doing volume.
46. When performing a utility usage analysis, what is the recommended number of months worth of data that you should collect? B. Yeah, the answer is B, 12. We want 1 full year. That way we get all 4 seasons represented so we can get a better idea of their heating and cooling loads. 47. While performing an energy audit on a home with an attached garage, you record the following measurements. House dimensions are 47 by 34, and the detached garage measures 16 by 27. The attic currently has 4 inches of rock wool insulation. Your work order should specify how many square feet of attic insulation.
This question has some conflicting language in it.
Yeah?
Because it says a home with an attached garage, and then the detached garage measurements are so.
I just took the garage completely out of it.
You don't care about the detached garage.
Right.
But it says in the beginning that it's attached.
I need to make a note of that.
Because it pretty much tells you there's an attached garage and then a detached garage, but you don't like.
If the garage was detached, what would the answer be?
Which is 47 by 34, so it'd be B.
Yeah.
Which is what I put down. I didn't know if it was.
Yeah, we had a couple of these questions, and I thought I had fixed them all, but I'll have to go back and take a look at this one. And it basically the way they were written, it left it extremely confusing because we couldn't figure out. Well, it really didn't tell you clearly whether the garage was here or the garage was, here. Yeah. And so when you were looking at the 47 by 34, we didn't know whether you had to subtract that or not. And we had conflicting answers. So watch for that. I think hopefully there'll be a better example either coming up here or on tomorrow's test that will.
Is B the answer?
B is the answer. Yeah. Okay. 1598. And it should be that basically that the garage is detached. So the garage is out here And the whole point of the question is that if the garage, actually, if it's a detached garage, it would not even matter. If the garage was an appendage to the house, then the point would be that we're only insulating the attic. If this is an unconditioned space, we don't need to be insulating over that garage. So we'll have to reword that question so that it helps you test what we're actually trying to test. 48. Where would you expect to find the vapor retarder on a wall assembly located in a predominantly hot, humid climate?
But
A. Toward the exterior of the wall assembly. Why?
To keep that humidity as far away from penetrating the house as you can.
Yeah, that's a good way to put it. Basically, this question comes up a lot, and it changes depending on whether your climate is dry or humid. In a dry climate, let's say this is our brick wall out here. That's our dry wall there. We have a wall assembly. In our dry climate here in Utah, where do we typically want the vapor barrier to be?
Or
In the wall assembly,
on
sorry,
the
the
wall?
vapor retarder, not the vapor barrier.
okay.
We want it to be on the inside of the house. And the reason why we want it to be on the inside of the house is because we're going to bathe and cook inside the house. We're going to create our own moisture in there. And then we're going to pressurize the house. We're going to try and drive that moisture into the building cavity like a bunch of fools. But if we're careful and we put a nice vapor retarder right here, then when we start to push that vapor into our building assemblies, it'll stop there, it'll condense there if we need it to, or we can exhaust it out somewhere else, but it doesn't make its way into the insulation and cause mold and stuff. In a humid climate, they still bathe and cook in their homes, but that only happens some of the time. What's happening most of the time is there's humidity out here that is always trying to permeate the building, and so we would then put our vapor retarder out on the exterior side to prevent that moisture from getting into the building cavity. So,
Did they ever do vapor retarders on both sides?
I would assume that some building engineers have sorted that out and tried to do that and do more of a sealed cavity. The only problem with that is in assembling that, if it's really not perfectly either vapor tight or it's vapor permeable, then you got a problem because if moisture does make it into the wall, you want it to be able to dry in one direction or another. So yeah, so usually the wall assembly is designed so that like this, you'd want your vapor barrier here or retarder here, but then the rest of this wall assembly would actually allow moisture to dry to the outside. But if it's moist out here, there's no point in doing that. So in our climate, it's okay for it to dry to the outside, but in a humid climate, then you'd actually want it to dry to the inside, and what they typically do there is run their air conditioners, and that dries the air out. But they do end up with a higher moisture content in their wall assemblies.
So unless you put an exhaust fan
Yeah,
in your cavities,
that in the humid climates, they're basically using mechanical ventilation and things like that, and air conditioning to regulate how much moisture is in their building cavities. If you take like in Oregon, if you're out on the coast, if you just have a house sitting there, no mechanical anything, the moisture is going to eventually build up in the wall and cause problems. So that's just the nature of it. I have a camp trailer that sat on the Oregon coast for 7.5 years. And then as I repaired it, rebuilt the floor and stuff. It was kind of interesting to find what I found inside, like just massive mold growths and stuff. Just from moisture sitting still, not really getting driven there to, mechanically or not, but yeah, in general, you'll see this question of like, in a humid climate or a dry climate, which side of the wall should the vapor retarder be on? And in my mind, that's the best way I've been able to sort it out, is that in a dry climate, we'll stop it here because we're the ones causing the problem. In the humid climate, it's always outside, so we'll put the vapor retarder on the outside to try to keep it out. But you can, and even building code officials will allow a little bit of leeway and discussion on that usually, depending on what you're trying to accomplish. But yeah, A is toward the exterior of the wall assembly on number 48. 49, where is the head jamb of a window located? D.
I guess D, because I'm thinking of a header, but I didn't know what a head jam was.
You got there by using like reason and logic. Even though you don't know all the terminology, and this could be terminology that maybe we have a standard terminology in our program and never heard of it. That's what it is at the top of the window. 50, what is the most effective way to determine the air tightness of an existing window?
D.
That's what I was thinking, but I put A.
Yeah, so this one, without reading the answers, I'm assuming this is probably going to be like, let's look at each answer, think about it, and pick the best answer. A says look for deteriorated rubber gaskets. That is a way to start to identify how leaky your window is. Check for proper closure and sash locks. Look up the manufacturer's rating for air leakage. I've never done that on the window, but they may actually have some specs on some windows for that. So all of those pass the make sense test. D, using chemical smoke while running a blower door, seems like it would probably be more effective than the others, but so yeah, the answer is D on that one. Okay. So you want to add up your scores, and don't tell them to me yet. I'll go ahead and shut our video off, and then we'll talk about that. But add up your scores, and you'll want to have that so you can kind of see your progress.